Alright, so you survived your first day of high school, first day algebra class, and we're going to go through the first lesson here. And this way you can kind of practice how to fill out the notes. Pretty straightforward, but these videos I'll do periodically through the year. They're not going to be very long. Just follow along and fill in what you need to fill in. You can have your book in front of you if you want, and we'll just kind of go through it here. First lesson's pretty introductory, and each lesson's got a big idea or a main idea that kind of covers the entire lesson. And for this first lesson of evaluating expressions, the big idea is that the order of operations is used to evaluate expressions with both numbers and variables. So there are some terms you got to know. The first one is variable. That's pretty important. Variable is a letter or symbol that can be replaced by a number. And basically, that's what algebra is all about, right? There's letters that stand for numbers. Often it's X or it's N, but it doesn't really matter. It can be lowercase, it can be capital. That's what a variable is. Algebraic expression is combining numbers and variables with operations. So plus, minus, multiplication, division. Algebraic expression basically is adding numbers and variables together. And then evaluating the expression is when you find the numerical value of an expression. So for example, if I give you a very simple algebraic expression like x plus 5, you would evaluate it by saying x is 2. So then evaluating the expression would be 2 plus 5, which is 7. That would be the numerical value. And of course you could substitute anything in for x. Order of operations. This is something that you've learned 5th, 6th grade. Probably learned some different devices for remembering that. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Of course, multiplication, division, and addition and subtraction are left to right all the time within exponents and within parentheses. So PEMDAS. Sometimes I've heard students remember this from elementary school as please excuse my dear Aunt Sally. Maybe you have a different mnemonic device that you can use. So here's a little summary out of the textbook with the order of operations. Perform operations within parentheses or other grouping symbols. We'll talk about some other grouping symbols as we go through the year. So within those grouping symbols, or if there are no grouping symbols, you always do powers left to right. You multiply and divide from left to right. And you add and subtract from left to right. What does that left to right mean? Well, if you had something very simple like 3 times 5 divided by 2, you'd have to do 3 times 5 first. You would not do 5 divided by 2 first. Same thing with addition and subtraction. Within an expression, if you had 2 plus 5 minus 7, you have to do 2 plus 5 first. So that's just a little summary of the order of operations. A couple things that you're going to want to jot down here in your notes. You see a little spot for them there. 2 definitions. These are going to be very common through the year. You've probably seen these before. This probably isn't new. The first is the algebraic definition of subtraction. And that says for all real numbers a and b, a minus b equals a plus the opposite of b. So 10 minus 7 equals 10 plus opposite 7. Or 20 minus 18 equals 20 plus the opposite of 18. All subtraction can get turned into addition. The advantage of that is when you are evaluating an expression, sometimes you can forget what the sign is for a number, if it's plus or minus. So this way, if you see plus, you don't make that mistake. The other thing is if you're combining terms, like 2x and 3x, you would make sure that you would combine those properly to 5x, but that's something we'll get to later in the year. And the other one here is the algebraic definition of division. For all real numbers a and b with b not equal to 0, a divided by b equals a times the reciprocal of b. So remember that reciprocals are always having a product of 1, so b and 1 over b are reciprocals because b times 1 over b equals 1. So if I used actual numbers here, 30 divided by 5 equals 30 times 1/5. It's the same thing. 40 divided by 8 is 40 times 1/8. 100 divided by 25 equals 100 times 1 over 25. You're going to get the same answer either way. And we'll see many different advantages to changing division into multiplication as we go on through the year. So you got your graphing calculator, TI-83 or TI-84. Remember, it doesn't really matter which one you have. If you don't have one, make sure you get one really soon. Here's just some basic keys that you should know. The squaring key, make sure you can find that on your calculator. The exponent key, it's like the little caret symbol. If you want to do a power other than 2, so if you were doing like 3 to the 4th, you would do 3 and then that symbol, then 4. And then the square root key, we won't get to that for a while, but that's the radical symbol, taking the square root of a number. Like square root of 10, you have to put that symbol in first. So just make sure you know where those 3 keys are on your calculator. Evaluating expressions and formulas. Basically, we're going to see some different formulas over the course of the year, and you just have to understand what letter stands for what variable. So sometimes in an expression there's a specific formula in mind. In this case, volume is equal to length times width times height. So the L has to be the length, the W has to be the width, and H has to be the height. There's many other formulas you're probably familiar with, but this is a common one. We'll deal with formulas throughout the year. So if length was 2, width was 3, height was 4, you would do 2 times 3 times 4. That would be the volume. And to finish up this first lesson, just very brief review, 3 important properties. Number 1, associative property of multiplication. Very important. For any real number, a, b, and c, the product of a and b times c is the same thing as the product of b and c times a. Order doesn't matter. We could also throw in there one additional true statement. That would be the product of a and c times b. 3 different things will all get you the same number. So if you use 2, 3, and 4 for a, b, and c, multiply them in whatever order you want, you're going to get 24 regardless how you do it. You can test that if you want. Addition is also associative, and you've maybe seen this in 6th or 7th grade perhaps, maybe last year. Addition works the same way. It doesn't matter what order you add, you will get the same result. So if A, B, and C are 2, 3, and 4, 2 plus 3, 5 plus 4 is 9. You're going to get 9 either way you do it. And then the final property here, let's wrap up the first lesson. For any real number a, b, and c, if a equals b and b equals c, then a equals c. The easiest way for me to illustrate this, if I have 3 students, if one student A has the same age as student B has the same age as student C, let's say they're both 14, then it has to be true that student A and student C are also 14. It's just simple logic. So transitive property is pretty important, something we'll also use through the year. So hopefully you got those notes filled out. Pretty straightforward. You'll get one of these every single lesson, as you can tell from the packet you got and I talked about today. So just be diligent, keeping those organized, and it'll help you follow along with all the material that we do. And we'll see you tomorrow.